Hello everyone. In this video, we will take a complete tour of the Akko push system, and I will explain the two systems included in it in a clear and organized way, starting from the very first setting in the component all the way to the last one in the actor, covering all the settings and the subsystems that each part depends on. The idea here is not just to show you these settings, but to understand what each part does, why it was designed this way, and how you can use it in your own project. So I will explain everything step by step in a simple way so that everything is clear from the beginning. Before we begin, it is important to clarify that the package is available in three versions. A version dedicated to the advanced push system, a version dedicated to the container push system, and a third version that combines both systems into a single package. No matter which version you have, this video will cover everything. If you need a flexible system for pushing regular objects of different shapes, there is the advanced push system version designed specifically for that purpose, with a large number of settings and customization options for pushable objects, along with solid support for the camera, sound, animation, and several validation tools that make pushing more stable, flexible, and much more. And here's the most important point. In the latest update, the system became much more flexible when dealing with differently shaped objects because it no longer relies only on a single box collision that covers the entire object. Instead, it now uses the actual mesh shape much more accurately. This opens the door to using it with objects such as chairs, tables, crates, and many objects that are not simply cube-shaped. If you are working on a project that requires a container pushing system based on physics, wheels, and precise alignment, then there is the container push system version. I am proud to say that it supports more than 60 different settings that you can modify and customize however you like. Currently, the system supports one specific type of container, the dumpster, but in the future, I plan to add support for more container types to make the system more comprehensive. And if you want both systems together, there is also a complete package that combines both systems into a single project. This gives you multiple options depending on the type of project you are building or the type of objects you want to work with. So I think that is enough explanation. So let us begin directly with setting up the system. After adding the system to your project, your folder structure will look like this. You will find that it is divided into two sections, Blueprints Base and Example Content Demo. You can delete the latter after taking the animations from it if you want, because you will not need it. Everything required for your system to work is inside Blueprints Base, so I will simply copy the animations into another folder here. Alright, the setup process is the same for both systems, and it will not take more than 2 minutes. Simply go to your character blueprint, and from there add the Akko push component. Then, inside Event Tick, create a sequence, and from the Akko push component, first get check push object M2 and connect it here. Then, in the second part, from the Akko push component again, get move value and connect it with the input action IA move, but we will do it in a cleaner way instead of placing it directly inside IA move. Finally, add camera limit sys as well. This is the basic system that it needs in order to work. After that, choose whichever key you want. For me, it is the F key. Then, from the Akko push component, once again, call try find close AC push, because this is where everything starts and where the actual pushing is executed. The final step here is that we need to add another mapping context. In versions earlier than 5.5, it will look like this image and should be added in Begin Play. However, in 5.5 and later, you only need to go to the player controller and add another mapping context from there. We can simply copy this section and paste it here, but change it to pusetch input, that it. Now, if you are using the container push system, there is one final step. In input action, IA move, you need to add stop move from the AKO push component and connect it to a branch. These are all the steps here. After that, we need to make one final change in project settings, where we will add the new object channels required by the system. For the regular push system, you need to add 2 channels, Unable Push and Other Push, and set the default response to block for both of them. For the container push system, you need to add these 4 channels: Alignment Simple, Alignment Complex, Idle Container, and Movable Container. And that is everything the system needs in order to work. One final tip specifically for container push system users: I highly recommend enabling substepping in project settings because it can be very helpful if you encounter any physics movement issues with the container later. It is a good optional setting, although it is not absolutely necessary. Now, if we try to run the system, you will see an error message like this, and that is completely normal. You only need to go to the exact location of the problem. Simply follow the error location shown by the engine, and it will take you directly to the Find the Face Wall Direction All function. All we need to do here is refresh this function, then compile, and the problem will be solved. Also, make sure that the out pin is correctly connected to alignment_complex and alignment_simple, exactly as shown here. And yes, let us do one final check here as well. Specifically, in the body, make sure that the collision is set to idle_container and not to anything else. Next, search the project files for master actor push. Once you find it, place it directly into the world. Also, make sure that this collision is set to push. If you followed the correct order with me when creating the object channels, you will find that everything has already been configured correctly by default. Now that we have finished the boring part of setting up the system, let us move on to the fun part and try it out. First, we will start with what I like to call the regular push system. Simply bring in any object to begin with. Let us test something simple, like a cube. Then let us change its appearance a little so we can distinguish it later from the original cube. After that, it is important to change the cube's pivot and place it in the center so the system works correctly. Also, go to the object settings, and from here, change the collision to project default instead of complex so that physics can work on the object later. Instead of the collision that we removed, we can create a simple box collision from here. Then replace the default cube inside it with the one we just created. Now let us simply try running the project. We walk up to it and press F, and yes, it immediately starts pushing. Of course, there is no animation yet, which is completely normal, and the pushing itself works properly without any problems. Now, to set up the animation, we will go to the folder where we copied the animations earlier, specifically to Anime Blueprint Push, and assign it directly to the character because it already contains everything we need to play the animation. Later, at the end of the video, I will explain how to set up the animation and replace it with one of your own. Yes, it is working well. It needs a little adjustment, but it works. At this point, we can say that the system setup is completely finished, and everything that remains is polishing and customization. And yes, do not worry. I will explain every setting you see here in less than 4 minutes, since they are not very complicated at all. So the first section we will start with is the general settings in the Akko push component. These settings are the same for both systems. Here we define the types of objects that can be pushed through object types push. Normally, you should already have the push channel enabled automatically if you added it with me at the beginning. If you are also using the container push system, then add idle_container as well, so the system can correctly distinguish between the different object types. Next, we have push range, which is simply the maximum distance the player must be within before pushing can begin. You can go here into Try Find Close AC Push and enable Draw Debug to see the range more clearly. The result will look like this. Next we come to Camera Index and Spring Arm Index. These two options are important if your character has more than one camera or more than one spring arm, because here you specify which one will be used while pushing. For example, if you have multiple cameras, choose 0 for the first camera, 1 for the second camera, and so on. If you have multiple spring arms, do the same. If, like me, you only have one camera and one spring arm in your character, then simply leave both values at 0. Next, we have use check method 2M2. When you enable this option, pushing will only be allowed if the player is looking toward the object. This gives you additional control over when the interaction starts, especially in first-person games where you want the character to be facing the object before allowing the push to begin. So from my experience, it is a very useful option. Then we have height of trace start M2, which is the starting height of the line trace used by this method, and how far trace M2, which determines how far the trace can reach. Finally, if we skip a few sections and scroll down a little, we reach the camera settings. First, you will find Enable Camera Follow Player. This option makes the camera follow the player's rotation while turning. To understand it better, just watch this video and you will immediately notice the difference. It is also a very good option for first-person games. Likewise, the next option, Use Limit Camera, simply limits the camera movement only while pushing. You can also control how restrictive the camera becomes using the limit angle pitch and limit angle yaw settings, depending on whether you want tighter or looser camera movement. Finally, you will find Use Camera Rotation Lag and Push and Use Camera Lag and Push. These options make the camera movement and rotation smoother while pushing. You can simply leave them enabled. Now, if we scroll back up a little, we will find some additional settings. First, push speed, which simply controls the pushing speed. Nothing special here. Next is amount turn, which determines the object's turning speed. The use turn in place option, when enabled, requires you to stop pushing every time you want to rotate. When it is disabled, you can rotate the object while continuing to push. Next, we have two important options, overlap count and turn and overlap count and move. To clearly demonstrate the effect of these two options, we go to the actor placed in the world, scroll down to the development option section, and enable Show Prediction Mesh. Enabling it will display the static mesh that the system uses for collision prediction. This is important because it lets you see what the system predicts before the collision actually happens. Its relation to overlap count and turn is as follows. As you can see here, with a value of 5, collision is detected earlier while turning compared to using a value of 0.5. So this value controls the turning collision accuracy. As for overlap count and move, it controls the collision accuracy while moving. However, this option only applies to the box collision detection method, which is something I will explain in a few moments. Finally, here we have the sound options. You can assign the default pushing sound that will be used while pushing. To get started, you can use the sound that comes with the system. You can enable Play Sound Stop Push to play a sound every time pushing stops. You can also use the sound that comes with the system. You also have Play Sound Hit Push, which plays a sound every time the object collides with an obstacle. You can later customize both of these by assigning any sounds you want. These are all the basic settings here that affect every pushable object in the world. Now we move to the settings of the object actor itself, which are the settings specific to each individual pushable object. So select the push actor that we created earlier, and here on the side you will find several options that I will explain as well. The first important option here is Enable Auto Adjust. This option makes the system automatically adjust the height of the push point so that it always stays on the ground. As a result, you will not need to manually adjust the height every time. Next, we have front/back offset, which is the distance from which pushing starts for the front and back push points. You can notice the difference here. After that, we also have right/left offset, which follows the same idea but for pushing from the right or the left with the same effect as before. Next, we have use uniform offset. This is very useful if the object's shape is similar from every direction, such as certain crates or square-shaped objects, because it makes the system use the same offset in every direction instead of requiring you to adjust each side manually. Next, we come to height arrow. By the way, this may be a bit late to mention, but these arrows represent the starting point for pushing from each direction. They are simply visual guides inside the editor to make it easier to see and adjust the push point location. When Enable Auto Adjust is disabled, you can manually adjust the height of these push point arrows. At this point, we reach a very important setting, Use Selected Move Type. If you enable it, the system will use the movement type that you manually choose in Selected Move Type. If it is disabled, the system will automatically try to choose the most suitable method. To explain it, there are two main methods. The first is sweep detection. This is a pushing method that relies on very precise collision detection while pushing. However, it can sometimes be too precise, preventing pushing, even because of very small differences between surfaces. This is where box collision detection comes in. It is much more forgiving, providing less precise collision detection but smoother movement while pushing, especially when you have multiple boxes stacked on top of each other. As you can see, it provides smoother movement than the previous method. And yes, it looks like we have a small issue here where the cube is clipping through the ground. The cause is most likely the ground's collision. Yes, just as I expected. Alright, now we can say that the problem has been solved. And of course, you can also push the object again after it falls without any issues. With that, both methods have now been explained clearly. Now, if we move to the next section and scroll down a little, we will find some more important settings. First, we have Block Push-Off Ledge. This is a very important option because it prevents the object from being pushed off an edge or falling from a high place. When this option is enabled, the system will stop the push before reaching the edge. This is where ledge check distance comes in. It determines how close the object can get to the edge before pushing stops. The higher the value, the earlier the pushing stops. The lower the value, the closer the object gets to the edge before stopping. You can adjust it to whatever suits your project. Now let us talk about the rest of the settings here. Can move forward/backward and can move left/right control, whether movement in those directions is allowed while pushing. Can turn right and can turn left control, whether turning to the right or left is allowed. There is nothing complicated here. These settings are useful. For example, let us say we have an object shaped like a door, and I will speed up this part a little so I can quickly make one here. Now let us say you want the door to be movable only to the left and right. You do not want it to be pushed forward or rotated. In that case, simply disable these options, and that is it. Now it can only move in certain directions. However, you will notice one problem, which is that pushing can still start from both the right and left sides of the object. This is where the next settings under the side push section come in. Here you will find Add Front Push, Add Back Push, Add Left Push, and Add Right Push. These options determine from which side pushing can begin. If you disable one of them, the player will no longer be able to start pushing from that direction. Continuing with our previous example, you can disable these two options, and now the object can only be pushed from the front and the back while still moving only to the left and right. Now we reach the final part of the system, which is the project's debug tools. The debug section is also important because it helps you understand the object's behavior during the different stages of pushing. The first and most important option is Hide Development Tool. You will notice two things. First, the arrows that represent the push points become visible in the world. Second, this text that appears on the object itself displays real-time information about it. As for Show Prediction Mesh, we have already talked about what it does. Next is Draw Debug Check Above, which displays the debug visualization for the check above test, mainly to verify the player's position. And Draw Debug Side Move Trace, which displays the box trace surrounding the player that is responsible for collision detection while moving. These are all the settings for this system. As you have seen, finally, I will quickly demonstrate one last example. You can make any object pushable by following the same steps that I explained. With a few small adjustments, you can create several different pushing systems for different objects individually, especially since the system itself provides more than 35 different settings that you can creatively customize to make every object behave differently. As a final note, with certain shapes, you may notice that you cannot push them when you get very close to them. This is not a bug. The reason is simply that the box used to check whether the player is standing on top of the object is a little too large. You only need to reduce its size by increasing the check player above margin value. This will solve the problem. Alright, I think we have covered this system thoroughly from every aspect. It is now time to move on to our next system, the container push system. Here things are a little different because we are no longer dealing with just a regular object, but with a complete system that relies on physics, wheels, alignment, and proper positioning before pushing begins. It is very important to mention from the beginning that this system depends partially on motion warping, so it must be enabled in your project before transferring the system into it, not afterward. This is a very important point because enabling it after the transfer may cause the system to stop working correctly. So we have already prepared the project for the system, so we will directly search for dumpster container actor and place it directly in the world. We will not need any modification, and we will directly test pushing it. And it works without any modifications or changes, and it already works. What we will notice is 3 things that need modifications. First, IK Hand is not enabled in the character, and also IK Hand debug. We need to turn it off. And by the way, I am talking about the blue and green points, and also the problem that the container does not move on slopes. These are the missing things, and they will literally need only a few clicks to solve them. So first, to solve the problem of not moving on slopes, we need to turn off this option here, lock rotation. After that, let's test. Let's move toward the slope, and yes, the container goes up the slope without any problems. This solves the first problem. Second, to solve the hands IK problem, we need to scroll down a little to here and enable IK hand and turn off IK hand debug. And yes, it was enabled immediately. As I said, just a few clicks to set everything up. But it is necessary to know that the IK system is still in the early development stage, so you may notice slight jitters. They do not really represent a problem, but they can be noticed in the hands from time to time. They will be improved and completely removed in the future. Alright, now before we finish setting everything up, there is one last thing, which is, if you notice, the player moves directly to the push point instead of walking toward it, and it is the same thing on all sides. To solve this, we go to the Push Positioning System section, and here we uncheck Direct Teleport. This will make the player move toward the push point smoothly instead of moving to it directly. That was everything regarding setting up the system to work completely. You can now use it without any problems. Next, I will explain the system settings, as well as the complete system settings, which, by the way, and I say this with great pride, exceeds 60 settings, which you can modify freely and smoothly. But just because there are many of them does not make them complicated, so do not worry. We will finish explaining them before you even notice it. First, inside the Akko push component, there is a section dedicated to the container settings, including motion warping index. This option determines which motion warping component will be used if your character has more than one. If the system cannot find a suitable motion warping component, it will automatically create a new one. This is important because the container system depends on precise positioning before pushing begins, not just on the movement itself. In short, it is the same idea as the previous camera index. The other settings here we have already explained, so we will skip them. The same thing here for the camera settings as well, so we will move directly to the container push system section, where we will find the settings related to our current system. First, we have push speed container, which determines the container's push speed, and turn speed container determines its rotation speed. After that, we reach a part that I consider important in the movement system. We will find several options here that are related to each other. The first setting is rotation acceleration, and it determines how quickly the container gains rotation speed. The higher the value, the faster the transition to the maximum rotation speed becomes, and the lower it is, the slower and smoother the transition becomes. Its benefit is not only that. The smooth transition in rotation prevents slight jitter problems in the container when there is a sudden change in rotation speed or direction, and this is its real benefit. After that comes max acceleration when pushing, and it is the maximum acceleration that the character can have while pushing the container. And push braking deceleration, and it determines how the movement slows down when stopping. But even if you modify them now, you will not notice any effect, and the reason is the smooth input system. So we need to turn off this option first to show you the effect of these settings. So first, max acceleration when pushing, and as you can see, it is a direct, non-smooth acceleration. After that, push braking deceleration, and the matter is clear as well. At low values, the stop is not immediate, unlike when it is set to a high value, where the stop is immediate. So all of these settings have one purpose, which is to control the movement of the container and the jitters in it by preventing sudden movements. But even these settings are not always enough, and this is where the smooth input system that comes with the system comes in. When enabled, it reduces sudden changes in input and movement, such as the quick transition from left to right or from front to back. It does not happen suddenly, but smoothly. The same thing applies to starting and stopping, which prevents any sudden movements that could affect the physical movement of the container. And to show its effect more clearly, I set it to a value of 1. With this, we have finished all the settings related to this part. Next, we will talk about the settings related to the container actor itself. The first setting is point offset, and it determines the distance of the push point itself. In other words, the distance at which the player starts pushing, whether close to the container or far from it. Next, we have enable blocking push. When it is turned off, the player will be able to interact with the container and move it by touching it. By default, this option is always enabled, and this is what prevents the player from interacting with the container, as you can see now. But for me, when the option is turned off, I see that the interaction with the container here is stronger than necessary. If you want to make the interaction here weaker than it is now, here is a suitable setting to modify for that purpose. In the character blueprint, search for push force, and here reduce the value to the level that you find suitable. This will reduce the intensity of the player's physical interaction with the container. Next, we will talk about the 2 rotation systems that the system contains. First, you will find that the Use Local Turn option is enabled by default, and when it is enabled, it uses the side opposite the player as the center of rotation, and this is normal behavior that you will find used in many games such as The Last of Us and others. And when it is turned off, it uses the player's own location as the center of rotation instead of calculating the previous center. The matter depends on your preference here. Next, you will find the Enable Auto Adjust Physics Constraint option, and simply, it automatically attempts to reposition the physics constraint player to a more suitable location based on the current setup. It is preferable to leave it enabled if you do not plan to change the location of the physics constraint that connects the player and the container later. Next, we have here some settings related to the container wheel system, which control stopping the push for the container specifically. Before I start explaining them, currently if we decide to start pushing until we reach the ledge, we will notice that the push stops automatically. This automatic stop depends on 2 settings. The first is airborne wheel, and this option determines the number of wheels that must lose contact with the ground before pushing stops automatically. If we try pushing after setting it to 4, this means that all 4 wheels must lose contact with the ground before pushing stops, and you can customize it even to 1 wheel. This depends on your settings. Next, we will find another setting related to the same wheel system here, which is wheel contact validation time, and it represents the amount of time the wheels must remain out of contact with the ground before pushing stops. It is better if I show you. If I set it to 2 and also set airborne wheel to 2, then pushing will not stop until 2 seconds have passed after the 2 wheels lose contact with the ground. It is useful so that pushing does not stop immediately if the wheels lose contact with the ground temporarily or for a short period. Next, we have number checkpoint, which determines the number of points checked on the ground between the player's location and the push point in order to determine the height difference between the surfaces. To show it to you more clearly, we can go down to the debug section and set this option here to 1 frame. I will not change anything in number checkpoint. Now, if you notice, some strange points have appeared here. These are the points that continuously check the ground between the player and the container. But this setting is only intended to increase accuracy and does not really affect anything. The setting that actually affects the height calculation is max allowed height. Before we talk about it, if I try to raise the position of the container as I am doing now and try to start pushing, you will notice on the side that there is a warning message saying that pushing is not possible, where it says that height distance is 40.5. What does this mean? This is simply related to the max allowed height variable that I talked about. It determines the maximum allowed height difference between the consecutive points that we saw in number checkpoint during the check. The lower the value, the stricter the system becomes with slopes and sharp changes, and the higher the value, the more height differences the system allows. Usually, values close to 15 or 20 are very suitable in most cases. I do not recommend this, but for testing, if we want to start pushing from the current height, we must set a value greater than the value that appeared previously in the warning, which is 41. And yes, now pushing has become possible, and it stopped immediately because the wheels lost contact with the ground, but it is possible even though I do not recommend it. Next, we have bottom trace extension. To show you its effect, we need to go down again to the debug options to enable this option. Now the box trace responsible for collision will appear, but what I want you to focus on is the extension at the bottom here, which covers part of the wheels. Simply, this option increases the downward extension of the collision more. If you sometimes notice collisions when going up steep slopes where the movement is not smooth at the beginning, then it is because of this, and you need to set it to a lower value or even 0. Next, we have the Use View Direction for Push Point option. This option determines how the push point is selected. When it is enabled, the system relies on the player's view direction to determine the push point, as I am doing now. And when it is disabled, it relies on the player's location to determine the push point, meaning it chooses the closest push point to the player. After that, we will find the Use Check Above option. When this option is enabled, it simply prevents the player from starting to push if they are standing directly on top of the object, and I highly recommend not turning it off. At this point, we reach the push positioning system. We already talked about it at the beginning, but briefly, since enabling the direct teleport option will make the player move directly to the push point without playing any animation. The opposite happens when it is disabled, and push positioning montage is the animation used to move the player to the push point. But what is really important is that if you have a different character, this is where the difference will be. First, you will need a walking animation that will play while walking toward the push point. You can choose any animation you want. It is only preferable that it is longer than 1.5 seconds. For me, this is the animation that I used. Then you create an animation montage from it like this, and here you will need to place a motion warping notify state over the entire animation, not just part of it. As for the settings, with warp target name, make sure it exactly matches the one in the push positioning system. It must match without any difference. Next, in rotation type, you need to set it to facing instead of default, and set warp rotation time multiplier to 0.1. This is all you need to do only if you have a different animation. Now we reach a very important part of the pushing system, which is the container alignment system with the wall. It is one of the most important parts, with several options here that we will explain together. But the first thing to understand here is that alignment does not happen randomly with any object. The wall or surface that you want the alignment to happen with must contain the appropriate collision type, either alignment_simple or alignment_complex. Let's take this wall that I created now as an example. We need to go to the collision settings. And if the wall uses complex collision, as it does now, then we need to change its collision here to alignment_complex. But let's say it uses simple collision instead of complex collision by changing its settings here. Then we need to use alignment_simple instead of alignment_complex. And it is very important not to make a mistake here. Otherwise, you will notice incorrect behavior in the alignment system later, so it is good to pay close attention to this part. That was the way to set up any object so that alignment can happen with it. And as you can see, when pushing against the wall, the container automatically rotates to align with the wall without any input from me. I only press the push direction, whether forward or to the right, and the alignment happens automatically according to the wall direction. Before we continue, if we go down to the debug section, we will find an option called System Alignment Debug. If we enable it, we will notice some basic things when colliding with the wall and automatic alignment starts. The first is Wall Direction Sphere Trace. It gives us the wall direction, and it also gives us the rotation direction value and the current alignment angle. These are the important things. The reason I am explaining them is because of the following settings that I will explain to you. You need this for a better understanding. First, we have alignment tolerance forward-backward and alignment tolerance right and left. These options determine when the rotation stops as it approaches perfect alignment with the wall. The higher the value, the earlier the alignment stops, and this helps reduce jitter when perfect alignment cannot be reached, and I will explain what that means. Currently, with the default settings, after colliding with the wall and finishing the alignment, you will notice that there is a very slight remaining rotation that did not finish, as it needed to rotate a little more to complete the alignment perfectly. Now, after changing the value here to a smaller value and trying again, as you can see, the alignment has become perfectly complete. This setting is only for forward and backward alignment, and for right and left alignment, we have alignment tolerance right and left, following the same logic, but for the right and left directions. With high values, we notice the same thing, that the alignment is not completely finished. And with lower values, the alignment becomes perfect. But there is a reason why I did not use small values from the beginning. As you may have noticed, with small values, there is a slight jitter before the alignment is completed, and this is the reason. Mathematically, there is a very small difference of 0.001 when approaching full alignment, and the system sometimes cannot reach this small value, so it starts jittering violently while trying to reach it. This differs from one object to another, but it is preferable not to use a very small value. Next, we have min alignment angle forward-backward and min alignment angle right and left. These options determine when the alignment system starts working, depending on the direction of the container relative to the wall. Let's start with forward-backward. Currently, if we tilt the container slightly and try to push it forward, the alignment will work without any problems. But if we change the value here to a higher value, we will notice that the alignment no longer works. Simply put, it has become restricted to a specific tilt. In short, when the min alignment angle value is greater than the angle of alignment value shown in the debug, the alignment will not start. The same logic applies to min alignment angle right and left, but with one small difference. Here, the alignment will not start if the min alignment angle value is smaller than the angle of alignment value. These settings are useful if you do not want the alignment to start from weak angles. Now we move to another setting, which is Enable Alignment in Back, which, honestly, I was thinking of removing. I mean, who would think of trying to align the container from the back? But I decided to leave it as an additional option if you want to enable it. After that, we find the Use Direct Direction option. Simply, this option uses the direct wall direction for the alignment calculations, which provides faster and more accurate results. So naturally, it should be enabled all the time, right? Well, yes, it should, but the problem starts to appear at wall edges, and I mean this. In rare cases, when colliding there, the system, as a result of the fast calculation, changes the direction quickly, which produces something similar to jitter. Therefore, if your world contains many narrow edges and you encounter such a problem, you can disable it, and it will solve the issue, because the system will then rely on the wall direction at the moment of the initial collision without repeated recalculations. Finally, here in the Advanced section, you will find collision correction strength. To explain it simply, it is the speed of the system in correcting the movement during alignment. Simply set it to higher values when the container speed is above 600, and set it to a lower value when the container speed in the system is low. That is all there is to it. The next section we have is the suspension system and its settings. You can look at this clip to see the difference when suspension is enabled and when it is not. The next section we have is physics. First, you will find the use wheel rotation option. You only need to enable it when you do not have a wheel support. To understand what I mean, I am talking about this. If you do not have this part and only have the wheels directly, then you enable that option. Next, we have lock rotation. It prevents the container from rotating on the X and Y axes while allowing rotation only on the Z axis. This also prevents it from climbing slopes. However, I strongly recommend not enabling it if you have slopes in your world. Enable this option only on flat surfaces to avoid any problems. Next, we move directly to Lock Z axis, which prevents movement on the Z axis to reduce unwanted vertical movement and jitter. This is very useful on flat ground and on many slopes as well, but on very steep slopes, the wheel positions may become slightly less accurate in some rare cases. So it is a matter of finding the best settings for your setup here. The last part here is wheels physics material. This section determines the physical materials used by the container wheels and controls their friction and how easily they slide on surfaces. The system includes 3 preset configurations ready to use. The first one, which is already being used, provides the maximum amount of grip with the least amount of wheel sliding. So even after releasing the container, it will not move very far. The second provides a balance between stability and sliding for general use, and makes the container move a little farther than usual. And the third and final option reduces the wheel friction, allowing the container to slide more easily and travel longer distances. And it is not only about sliding down slopes, the effect is also present on flat surfaces. As for the audio, the system is simple and straightforward. You have push sound, which is the sound that plays while pushing the container, and rotation sound when rotating. An initial impact sound when the container touches the wall for the first time. Then, container aligned sound when the container becomes fully aligned with the wall. And each of these sounds has its own independent volume control, which gives you very good flexibility in adjusting the overall feel of the system. Next, we have the hand IK section. The first option here enables or disables hand IK, which, by the way, I will explain separately later if you have a different character. After that, we will find a group of useful settings related to it. First, hand IK distance. This option controls the distance between the right and left hand positions. Lower values bring the hands closer together, while higher values increase the distance between them. Correct hand forward backward. Adjust the hand IK positions forward or backward relative to the container handles. And finally, correct hand height. Adjust the hand IK positions up or down relative to the container handles. We also have an additional option here, which is IK hand debug. It shows you the actual IK position on which these calculations are based. Now we reach the last part here, which is the debug tools section. We have already shown the benefit of some of the tools, but there are still some that we have not talked about. The The first option here is hide the real wheel. The idea here is that the system relies on two types of wheels: real wheels that are responsible for physics and suspension. This option hides them when enabled, and they appear in green. And fake wheels that display the movement in a cleaner way and closer to the actual movement of the container. The real wheels are not supposed to look visually synchronized with the movement of the container because they simply work with the physics. Next, we have hide debug line. When you disable this option, two lines will appear. The first is black and represents the forward direction of the container, and the second is red and represents the movement direction of the container. Then there is hide dev tool in the game, which hides the development tools during final gameplay so that the push points, lines, and helper elements do not appear. Disabling it does the opposite and shows them. We also have show pivot location, which displays the location of the pivot used when local turn is enabled. Then there is show physics debug message, which displays physics information on the screen, such as the center height value, the twist limit and swing limit values, the Z limit value, the enabled or disabled state of Z limit, and the rotation state itself to determine the condition of the container in different situations. After that, we reach Draw Debug Check above, which displays the check used to determine whether the player is standing on top of the container. Then Draw Debug Side Move Trace, which displays the box trace used for side movement. And Draw Debug Push Hit Trace, which displays the box trace used to detect collisions that may prevent pushing or cause overlap. And Draw Debug Rotation Trace, which displays the box trace used for rotation and detecting obstacles before rotating the container. With this, we have finished all the settings for both systems together, with a comprehensive explanation of every section and every setting in them. Before we conclude the video, I will quickly show you how to prepare your own animations for the system in an easy and clean way. In your animation blueprint, all you have to do is get these variables shown here. And of course, this is done. After casting to your character, just use getComponent by class to retrieve the AKO push component. And make sure that you are using AKO push component. After that, use calculate push speed to get the actual speed while pushing. This will give you the forward and backward speed, and the player's movement speed to the right and left. Use push, which becomes true while the character is actively pushing an object. You also have isTurnRight and isTurnLeft. And finally, stop turn, which determines some situations in which rotation becomes stopped. In the last part here, you have the IK location for the right and left hands, as well as a variable that determines when the IK is enabled. These are all the variables that you need to use when you want to customize your own animations for the system. After that, you can open this specific animation blueprint to get an idea of how to use each variable correctly. With this, we have gone through the complete structure of both systems, from the AKO push component to the object actor and container actor settings, then the movement, camera, audio, IK, debug, and all the core parts on which the project depends. With the package, you will also find example content and additional documentation that will help you understand the system quickly and test it inside your project, whether you are using the standalone version or the package that combines both systems. If you encounter any problems, there is also complete documentation explaining how to set up the system and solve some of the common issues. And if you find yourself facing the same problem, you are more than welcome to contact support through Discord. I will reply to any questions as soon as I notice them.